Hi there, folks. Today we're looking at exploring different angle pairs and the relationships that certain angles have. So, diving right into it, the first one we're looking at here is adjacent angles. And if you know what the word adjacent means next to. All right. So, two angles with a common side, common vertex, and no common interior points. Essentially, it's just saying that, hey, these two angles are pressed up against each other. All right. They're not overlapping, so they don't kind of share any points in between. All right. But they share one of their sides. They're up against one another. And so when we look at these angles 1 and 2 here, those are adjacent angles. All right, because we have two distinct angles that are up against each other. Same thing here with angle 3 and 4. They're adjacent angles because they're two distinct angles, but they're pressed up against each other and they're sharing one of their sides. And so in this one, it's sharing this middle piece, and this one, it's sharing this guy. Okay. The next type of angles we're going to look at is vertical angles. Vertical angles are two angles whose sides are opposite rays. And, the definition is probably the worst way to think about vertical angles. I hate to say that, but vertical angles are basically formed when we have lines that cross, all right? And the vertical angles are the ones that are kind of opposite one another, all right? So when we look at this one, vertical angles here, angles 1 and 2 are vertical angles. So angle 1 and 2 are vertical angles. Okay, and I'll often abbreviate vertical angles as just vert. All right, 3 and 4 are vertical angles as well. So angle 3 and angle 4. And again, the definition doesn't really make a lot of sense usually to students. When you really start to look at it, when you visualize vertical angles, it's a lot easier. It's easy to see, hey, two lines are crossing. The angles are kind of opposite one another. Those are vertical angles. All right. The idea of two angles whose sides are opposite rays comes from this. See, this guy and this guy are opposite rays. And then this guy and this guy are opposite rays. And so when you think about it, angles 1 and 2, all right, they're formed by opposite rays. Angles 3 and 4 are formed by opposite rays. And so that's the idea. Again, visually, it makes a whole lot more sense than the definition would kind of lead you to believe. But if two lines cross, essentially, all right, because that's what opposite rays form, if two lines cross, the angles that are opposite one another, those are vertical angles, okay? Complementary angles. Complementary angles are basically angles that add up to 90 degrees. All right. And this can be adjacent angles, but they don't have to be adjacent angles. So they could be adjacent. They could just be separate angles. If they add up to 90 degrees, they're complementary angles. All right. And so if you look at that first one, I know that those add up to 90 degrees because that little box, there's that symbol again. That little box means it's a right angle. Right angles are 90 degrees. So using the angle addition postulate, angle 1 plus angle 2 has to equal the entire angle. So 1 plus 2 has to equal the 90 degrees. Okay? And so those are complementary because they add up to 90 degrees. Separately, if I look at angles A and B, those are complementary because I'm just looking at the measurements, and the measurements add up to 90 degrees. All right. And so these are kind of nice to look at when you look at these two separate examples, because one of them, there's not even any measurements given, but I can identify them as complementary. Okay. So yes, they add up to 90 degrees, but that might not always be as obvious as just seeing numbers written down that add up to 90. You might have to look for those symbols and think about some of the other concepts that we've talked about. Okay. Supplementary angles are angles that add up to 180 degrees. And once again, if I kind of split these into a couple different categories here, the first pair, those are some adjacent angles, all right? And the way I can tell that these are supplementary is because that's a line. Remember, when I look at that thing that's drawn across the bottom of 3 and 4, that is a line, which means it's a straight angle. Okay? And if it's a straight angle, it means it's 180 degrees. And then once again, talking about my angle addition postulate, angle 3 plus angle 4 have to equal the whole angle. And if the whole angle is 180 degrees, then angle 3 plus angle 4 have to equal 180 degrees. And so it's that idea that even though there's not any measurements given here, I can tell that those are supplementary based on the angle addition postulate. Likewise, they don't have to be adjacent angles. Again, just like complementary, they don't have to be adjacent. If I look at angles A and B, those are not adjacent angles, but they still add up to 180 degrees. Therefore, those are supplementary angles, okay? So complementary add up to 90, supplementary add up to 180. For example, if I look at something like this, and one of the really important things in geometry when we look at pictures, especially pictures where there's a lot going on, we can't make assumptions, okay? You can't assume that something is 90 degrees because it looks like 90 degrees. We either have to be able to add it up to 90 or we need that symbol. We can't always assume that lines, that things that look like lines are lines, all right? Most of the time I'll include in a picture, I'll say, hey, if it looks like a line, assume it's a line, okay? But don't always make those kind of assumptions. Sometimes there's not enough information to answer a question, all right? So make sure you're answering it based on the information given and not on the picture that you see, all right? For example, if I look at this guy, it says name a pair of adjacent angles. Remember, adjacent angles are just any angles that are touching. And there are a lot of different options here. I'm going to go with, I'm just going to pick a set here. So maybe I'd say like angle AFB. And if I started with angle AFB, I just need to find another angle that's touching AFB. So maybe I would do like BFC, all right? And notice they share a ray. They share ray FB, okay? And there's a multitude of other answers that you could pick here. I could have done angle EFD and angle CFD, all right? Or any other number of combinations. So adjacent angles are just angles that are touching one another. Okay? Side-by-side angles. Then the next question says, are BFD and CFD adjacent? And so I have to kind of scoot over here and say, okay, BFD would be this one. CFD would be this one. And the question is, are those adjacent angles? And at first glance, you might think, yeah, because they're touching, but one of those angles is inside the other. Remember, adjacent doesn't mean inside, it means next to, okay? Adjacent means side by side, and those aren't side by side. One of them is inside of the other one, and so those are not adjacent angles, okay? So no, those are not adjacent angles because yeah, they share one of their sides, but one of them is inside the other. So remember, it's side by side. They're separate but touching, okay? Name a pair of complementary angles. I just have to look around for any two angles that add up to 90 degrees. And it looks like the 62 and the 28 add up to 90 degrees. So therefore, angle AFE, that's the 62-degree angle, and angle BFC are complementary. They add up to 90 degrees. And there might be other angles that add up to 90 degrees here, but I don't have enough information to say that any of these other ones do because some of them aren't labeled. You know, maybe CFD and BFC add up to 90 degrees, but I don't know. It looks like it could be close, but I can't say for sure, so I cannot list those as complementary. Okay? Name a pair of supplementary angles. So supplementary angles add up to 180. If I do the 62 plus the 118, that adds up to 180. So angle AFE again. And angle, the other one was DFE. That was the 118. Those are supplementary because they add up to 180. Okay? Do I think maybe there's other ones? Like, it looks like AFD might be a line, so maybe I could say AFB and BFD, but I can't say for sure because nothing else is labeled here, okay? Maybe that's a line, but maybe it's not, okay? So I can only go with the information that's given. Don't necessarily trust your eyes on this, okay? The next one are CFD and BFC complements. And so this is the one that I kind of called into question a moment ago. CFD and BFC, they look like they might be complements, but I can't say for sure because there's not enough information given. So what we typically do here is we say no, and we say no because frankly we don't know. There's not enough information, okay? So So not enough info. And that's one of those things where students really struggle in geometry is we want to look at the picture and we want to make assumptions, but we can't, all right? If the information isn't given, we can't say for sure. We're only looking for what can we say for sure? What are we positive about, okay? Name a pair of vertical angles. Again, in order to have vertical angles, I need to have two lines, and it looks like AFD and AFC are lines. So maybe I have some vertical angles there, but there's no way for me to know for sure. I know that AFD is a line because the 62 and the 118 make a 180. That's a straight angle. But the problem is I don't know about this guy right here, okay? If I knew that guy was a 62-degree angle, then I could say that this guy is a straight angle, all right? But the fact of the matter is I don't have enough information to say that. So I can't say for sure. So I'm going to say, well, we don't have enough information. Okay? Do we think those are vertical angles? It looks like it, but I can't say for sure. So not enough info. Okay? If I look at something like this, guys, so that same theme of, hey, what am I allowed to say and what can't I say? All right. So making conclusions about the diagram, and this is kind of open-ended. We're just going to start kind of rattling things off and see what we come up with. And notice the information that's given in the picture. Okay. Remember those symbols. There's different symbols that tell us different things. Like that cursive L and that cursive M are telling us that those two things are lines. See, I know for sure that this is a line because of the way it's labeled right here. All right, because it's labeled as a line, I can say for sure that that thing is a line. All right, and same thing here with M. I can say for sure that this guy right here is a line because it's labeled as a line. All right, that's what that labeling is telling me. And then you see those little green arcs. Well, remember, if they have the same, two angles have the same number of arcs, it means that they're congruent. All right. So we can start rattling off some of this stuff. The first things I would point out is that, hey, I've got two lines, so that's helpful information. So L is a line because it's labeled as a line. I could also say that M is a line because, again, it's labeled as a line. All right. The other thing that's labeled here for me is that angle 1 is congruent to angle 2. And I only know that because the picture says so, all right? And so this is kind of the foundation for what we're going to get into when we start proofs. But, understanding what the picture is telling me, understanding what I'm starting with, now let's talk about what else do I have? What else do I know? And so, it's kind of random how you might spout these off, but maybe you would say, hey, angle 3 and 4 are supplementary. And maybe you're looking at that going, well, how do you know they're supplementary? Well, M is a line, right? Well, so a line is a straight angle, so M is 180 degrees. So that means 3 and 4 add up to 180, okay? And I can say that for sure because M is a line, it's a straight angle. And then going along those same lines, maybe I'm looking at, well, L is a straight angle too. So that means angles 4 and 5 are also supplementary angles. Okay? And so that idea of, all right, because I know those are lines, now I know other stuff. And maybe you'll look at this and go, hey, wait a minute. If those are lines, I have a vertical angle situation. So angle 3 and angle 5 are vertical angles. Okay? And so, again, we have all this information based on just a very small amount of information. And, there's all kinds of things that we can keep going and keep doing here. We could maybe put some extra labels in here like, A, B, C or something like that. And it's okay to add labels to this thing. See, because now you could say that angle ABC is vertical with angle 4. All right. And so, again, the idea here is just trying to kind of list as much as possible that we can figure out. And there might be more things we can come up with. We'll kind of stop there. But this is the foundation for how we do proofs in geometry and how we solve problems. It's that kind of logical progression of, if I know this stuff, What else do I know? Okay. And so again, some of these angle pairs that we've explored, we can figure some of those things out just based on very little information. All right. But what does that information tell us about other things? Okay. Let's talk about a linear pair. A linear pair is really easy. All right. Basically, if we have a line and a ray coming off of it, it forms a linear pair. It forms two angles that are basically adjacent, and their opposite side, their non-common side, form opposite rays. In other words, the side that they don't share makes a line. Okay, and that's why it's called a linear pair. That word line, it's a linear pair. It's a pair of angles forming a line, all right, and they're adjacent. So this one and 2, those are a linear pair. And probably the most obvious thing after exploring what a linear pair is this postulate right here. If two angles form a linear pair, then they're supplementary. Well, of course they're supplementary. They make a line. They make a straight angle. They make 180 degrees. So if I have a linear pair, it makes a 180-degree angle. Well, that's almost the definition of supplementary angles, okay? Two angles that make 180 degrees, that make, all right? And so this is the situation with supplementary angles where we have adjacent. If it's adjacent supplementary angles, we're talking about a linear pair. If we have a linear pair, we know that they're supplementary, okay? Because they add up to a line. They add up to that 180 degrees, a straight angle, okay? For example, if I look at something like this guy, it says find the measure of each angle. And for this one, we'll assume that this is a line here. COB is a line, all right, forms a line. So that's a straight angle. So this is a linear pair. All right, it's two angles that make a line, which means they are supplementary. They add up to 180 degrees. And so the way we say this, we would say, hey, that means that I can take the 2x plus 24 plus the 4x plus 36 and say, hey, that equals 180 degrees. All right. And it's the same kind of concept as this is still built on the angle addition postulate. The two angles add up to the whole thing. The whole thing just happens to be 180 this time, okay? And so I combine like terms. That's a 6x plus 60 equals the 180. And now I'm going to subtract that 60 from each side. And I'm going to divide by the 6, and I get 20, all right? But notice it didn't say what is x equal. It said find the measure of each angle, all right? So once again, in algebra, typically we stop here and we say, all right, we're done because, we got x. It didn't ask for x. It asked for each angle. So make sure you plug that x back in. So right here, 2 times the 20 is a 40 plus the 24 it's a 64 degrees. And then once again, instant check here. Let's plug the x in, and then we'll see if they add up to 180. So I plug the 20 in for the for the x here. So 4 times 20 is an 80, plus 36 is a 116. And so we just have to ask ourselves, okay, if I add those together, does it give me 180? And the answer is yes. So guess what? I must have done it correctly. Okay, but these are supplementary angles, and they're supplementary because they're a linear pair. Okay. The last relationship we're going to look at is an angle bisector. An angle bisector is basically a ray that divides the angle into two congruent angles. All right, and it's the same thing that we looked at when we looked at midpoint or segment bisectors. Okay, a midpoint or segment bisector cuts a segment into two congruent pieces. All right. An angle bisector cuts the angle into two congruent pieces. It cuts it in half. All right. For example, and again, once again, we label this with arcs. So if they have the same number of arcs, it means that we're looking at an angle bisector. Those angles are congruent. All right. So 1 and 2 are congruent. So this one says find the value of x if ray AB is an angle bisector. And this time it did ask us to find x. It didn't ask us to find the measure of the angle. But if it's an angle bisector, it means this guy and this guy are congruent. Now, the first thing I do is I draw on the picture and say, hey, these are congruent. Now, visually, I can see that. And so if those are congruent, it means that the 6x minus 9 equals the 27. And now I can solve. I add that 9 to each side. I divide by the 6, and I get x equals 6. And that's it. And you notice why it didn't ask me for the measurement of that angle? If it had said, hey, find the measure of angle BAC, well, we don't need to do any math. It's 27. It's got to be the same as the other one, okay? But we can instantly check this by plugging the 6 back in, okay?